In this video, we're going to briefly look at the idea of arithmetic sequences. Now, arithmetic sequences are just sequences of numbers, but specifically where each term is separated by the same amount. So in the example on the left there, you can see that we've got the numbers 1, 3, 5, 7 and 9 and so on, and that's a sequence of numbers. But importantly, they're separated by a plus 2. So from 1 to 3 you have to add 2, from 3 to 5 you have to add 2, 5 to 7 add 2, 7 to 9 add 2, and if you added 2 again you'd end up with 11, and you keep going. So that's an example of an arithmetic sequence. Over on the right you can see another one, 19, 14, 9, 4, minus 1, minus 6. It looks a fair bit different from the first example, but that's because our common difference is a negative value, minus 5. So 19 minus 5 is 14, 14 minus 5 is 9, and so on down the line. So in this particular one, the next number along would be minus 11. Minus 6, take away another 5. So here's an example, 5, 9, 13, 17, 21, and so on, we're being told is an arithmetic sequence, but you can check that if you like. The first question then asks us, what is the common difference D? Okay, so remember the common difference is just the difference between each successive term. So you could have a look at that any way you like. You could pick up any term because it's a common difference, but I'm just going to go with the first. So to get from 5 to 9, we have to add 4. So our common difference is going to be D equal to 4. Second question then is, what is the next term? So we've got 5, 9, 13, 17, 21, and we're not given the next term. So the next one would be 21 plus that common difference, which is 4, which is equal to 25. So our next term would be 25. Just quickly, if you wanted to check that first answer for the common difference, you could have a look at some of the other terms as well, and you'd see that the common difference there is 4 between each of those successive terms. There are some rules that we've got associated with arithmetic sequences, basically rules that tell us what the terms are. Now, the easiest one is where we've got one of the terms and then we want to figure out the next, just like we did in the example there. And because the terms in an arithmetic sequence are always separated by a common difference, D, we can write this equation here. So I'll read that one out. Tn is equal to Tn minus 1 plus D. So what that means is if I have a term, which I'm going to call Tn minus 1, and I add the difference D to it, that'll tell me the next term along Tn. So see what the n and the n minus 1 means there. N minus 1 is the one you've got. The next one along would be n. Okay, so in this example, 1, 4, 7, 10, I've got a common difference of 4 minus 1 is 3. T4 in that sequence is 10. So then I'm going to say that T5, using our formula up here, T5 is going to be T4 plus the difference, which is 10 plus 3, and that's going to be equal to 13. So the fifth term in that sequence would be 13. Add the D again, you get 16, that's going to be T6. A more general rule you can get to is one where you don't actually need to know the very previous or the very preceding term. Okay, so if I just wanted to know any old term in a sequence at all, like the millionth, for example, I don't want to go through having to figure out 999,999 other terms. So we want a more general rule. And we can figure one out using the ideas that I've got on this page. So let's just say we have an arithmetic sequence where the first term is some number A. Okay? The second term then would be A plus the common difference, A plus D. If we go up to the third term, T3, that would be A plus D again, or A plus 2D. The fourth term then would be add another D to that, A plus 3D. And sure enough, for term 5, we'd have to add D again, and we'd get A plus 4D. Now, you might be able to notice that the numbers here are increasing by 1. So are the numbers in front of the D. But they're always sort of lagging by 1. So term 5 is A plus 5 minus 1D. Term 4 is A plus 4 minus 1D. It's always the number of the term you're looking for, minus 1, multiplied by the common difference. So if we wanted to talk about it in general, Tn, where n could be any number we want to, we'd have to have a again, plus how many d's would we have had to have added? Well, it'd be one less than the term we're at, so n minus 1. N minus 1 times d. Okay, so that's our general rule for any term in an arithmetic sequence, the nth term. Let's take an example. Over on the right, an arithmetic sequence has the first term minus 9, so that means that a is equal to minus 9, and the common difference is 12, so I'm going to write d is equal to 12. And the question is, what is the ninth term? Now, I mean, 9 is not very big, so I could actually just go through and figure it out. Minus 9 plus 12 plus 12 plus 12 and so on. But just to show how to use the formula over here, we're looking for the ninth term, so T9 is going to be equal to A, which is minus 9, plus 9 is n, so 9 minus 1 times d, which is 12. Okay, so that's minus 9 plus 8 times 12, minus 9, whoops, not multiply, plus 96 is going to be 87. Okay, so our ninth term is 87. Okay, so that's a little bit about arithmetic sequences, what they are, some of the important characteristics of them, the common difference basically, and then some formulas for figuring out terms in these sequences.